Alright, this is my Chapter 7 problem presentation. It's a question from 7.4, homework number 5, and it's like number 47 in the book. The question is, write and evaluate the definite integral that represents the area of the surface generated by revolving the curve on the indicated interval about the y-axis. The equation was 1 minus x squared over 16 from 0 to 4. The graph looks something like that, and the equation for the surface area is the integral from a to b 2 pi rx with the square root of 1 plus the derivative squared dx. To get the derivative, I made the equation 1 minus x squared over 16, which then the derivative of that is negative 2x over 16, which with that simplified, it's negative x over 8, and that is the derivative. And Rx would equal just x because it's rotating around the y-axis. So then I plugged everything in to the surface area equation, which then turned out to be from the integral from 0 to 4, 2 pi x times the square root of 1 plus negative x over 8 squared dx, which then I did some work, and it turned out to be, I just moved the 2 pi out, which then it was 2 pi from the integral 0 to 4 x, the square root of 1 plus x squared over 64 dx. And I noticed that I could just set that equal to u by using u substitution. So then it was, I let u equal 1 plus x squared over 64, which then du equaled x over 32 dx, which I multiplied the 32 in so that way I could get the x over 32 to match dx. And then I substituted the 1 plus x squared over 64 to be u, so the 1/2 for the square root du. And that equaled 64 pi times 3/2 u to the 3/2 because I took the integral. And since I did u substitution, I made the original bounds, which were x equals 4 and x equals 0. So then I plugged them into u, and it was 1 plus 4 squared over 64, which then became 1 plus 1/4, which was then equal to 5/4, which was one of the new bounds. And then x equals 0, when I plugged in to u, was 1 plus 0 over 64, which was just 1. And that's how I got those two new bounds. Then I used the fundamental theorem of calculus, which then it would equal 64 pi in times 2/3 times 5/4 to the 3/2 minus 2/3 times 1 to the 3/2, which that equaled 64 times 2/3 times the square root of 125 over the square root of 64 minus 2/3, which then that equaled 64 pi times 2/3, which then I simplified the 125, the square root of 125 over the square root of 64, which then became 5 times square root of 5 over 8 minus 2/3, which that equaled 64 pi times 1/3 times 5 the square root of 5 over 4 minus 2/3, because I simplified when I multiplied the 2, I simplified the 2 and the 8, which then just equaled 5 over square root of 5 over 4. Then I multiplied the 1/3 into the 5 square root of 5 over 4 minus 2/3, which then I just made the 2/3 have the same denominator. And then I multiplied in the 64 pi into the rest of the equation, which then I could just simplify a 4 out and make it 16 pi times 5 times the square root minus 8 over 3. And that's how I did this problem.